Hello PreCalc, it's Wednesday and we're looking at the sum of a geometric series. Let's remind ourselves what a geometric series is before we look at the sum of one. So for example, if we have 3 and a 9 and a 27 and an 81, we have what's called a sequence. So a sequence is geometric. If there's a number, you can multiply each term to get the next. So is there such a number? Yes, in this case, multiplying 3 by 3 gives me 9, times 3 gives me 27, times 3 gives me 81. We call that the common ratio, R. Now, if I presto changeo these commas to plus signs, I now have what I call a geometric series. So a series involves a summation of numbers. So when we sum those numbers up by hand, it looks like we get 120. So last time we had a fascinating development of the formula for the sum of a geometric series. Where R again is the common ratio, N is the number of terms, and A sub 1 is the first term. So let's do this simple one. Of course, in real life it was that quick and short. We would do it by hand, but let's see if the formula even works. I see doubt in your eyes, Maggie. So let's prove it to her once and for all that this works. S sub 4, I'm adding the first 4 numbers in this series. A sub 1 gives me 3. 1 minus R, the common ratio is 3, raised to the n, and there's 4 terms, all over 1 minus 3. So I plugged in everything into this formula, and here's what comes out. 3 to the 4, 3 times 3 is 9, times 3 is 27, times 3 is 81. So I get 3 times 1 minus 81. Please remember to do this first. This does not turn into a negative 2, 1 minus 3, because this exponent must be applied to the 3 first. And on the bottom we have a minus 2. So what does that give us? This is a minus 80. So we have negative 2 into negative 80 goes 40. 40 times 3 is 120. Alright, so it does work. So there, same answer. So now that we have full trust in our formula, we're going to go ahead and use it on ones where we actually need it. And usually they don't, in your book, they're not going to look like this. They're going to look like this because you guys are so capable now. Here's what the problem will look like. Let me scoot down here. Try to keep the formula in view. Alright, so you're going to look like that because that is a summation. And you're going to have some counter. I'll call this one I, but it can be N or K or Q or whatever. 4 times 0.03 to the I minus 1. The first step in order to use the formula to find the summation, so we're summing up some 12 different terms, because remember when we go through this, first I takes on 1, then it takes on 2, then we add each term, and that's what this means, summation. So let's generate a few. And when you put 1 in for I, you get 0 as an exponent. Anything to the 0 is 1. 1 times 4 is 4. So make sure you get 4 out of that first iteration and not 0. So then we automatically know that we're going to sum these because this is a summation. So now we go when I equals 2. 2 minus 1 becomes a 1 as an exponent, and we have 4 times 0.03 to the 1. I'm not going to multiply it out so I can see the pattern. Then when I goes up to the next one, 3, 4 times 0.03 times, actually, you know, this problem was supposed to be 0.3. I'm sorry. so I can give us all the same right answer. If you would change that, it won't change our first. It won't change our first number. It's still 4, but it will change this to 0.3. All right. So then our next one is 4 times 0.3 to the 2, and so on. And we're going to go down how many terms? 12 in all. So how many 0.3s will be in the last term? So in the last term, when we get to the 12th term, we see there's no 0.3 in the first term. There's 1 in the second term, 2 in the third term. So in the last term, the 12th term, there will be 11. So patterns tell us these things. All right, so now we're going to use this formula. I'll rewrite it so we can bring this all in the screen down here. Sort of a funny reflection. Let's see if it's any better here. All right, so again, S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. All right, so I'm going to add the first 12 terms, so that's S sub 12, and I am looking for, I like how that's not showing up so good. This part is kind of in a shadow or in a glare. I guess it's in a glare. All right, I'll try and prove it. Then everything else is in the dark. Let me try some other lighting. All right, I don't know if that helped or hurt, but anyway, I'm going with it. So a sub 1, the first term, grab it. 4 times 1 minus the common ratio. What did I multiply this term to get this one, and this term to get this one? Can you see 0.3 was used over and over, and that's going to be raised to the n, and that's 12 over 1 minus 0.3. So when I tapped that into the calculator, I came out with 5.7. 1/4, something like that. So that is the sum of all these terms. All right, what happens if I change that slightly to this? I equals 1 to 12, 4 times 0.3. This time it's only to the I. So both of these are in the screen now, and the difference is right here. I have I instead of I minus 1. That's why I've asked you to generate the terms, at least a couple, so you can use this incorrectly. So let's see what happens. When I is 1, I get 4.3 to the 1, 4 times 0.3 to the 1. And when I is 2, I get 4.3 to the 2, and so on. So I'm going to go on out to the 12th term. I'll get 4 times 0.3 to the 12 this time. But here's how that changes when I go to put it in our formula. I can still see the formula here. So right here. So I'm going to put in my values. S sub 12, the sum of the first 12 terms, is the first term. 4 times 0.3 is the first term. Notice in the previous one it was not. Then times 1 minus, we still have 0.3 as the common ratio, to the 12, all divided by 1 minus 0.3. So you can see the difference was right here, but it will create a different answer. So I failed to tap that out. So if you would tap it out for me, we can get that answer. All right. It will be different than the 5.714. Let's go on though, so we won't spend a lot of time. I just want to call your attention to that issue. Let's go on, and I'd like to give you one to do, and I'll just leave it with you, and you can work that out and bring it to class right in your comp book. So we're going to go the summation. N goes from 0 to 20 of 10 times 1/5 to the n. So go ahead and find the sum. You're going to use this handy dandy formula right here, and you're going to generate a couple terms so you can clearly see what the first term is. And you're going to be careful when you decide what your n is, the number of terms, because we're starting at 0 this time and going to 20. So configure in your head how many terms that will be. That will be your n. Alright, so I'll leave that one with you, and I'd like to answer in fraction form. So if you come out with a decimal, please change it to a fraction and do it in your comp book right now so that we can check it all together when we come in. Alright, so that is how you use this formula. I hope you find that compelling, interesting, and useful. Alright, till tomorrow. Goodbye.